Hey guys, this video is brought to you by Dev Mountain. Dev Mountain is an in-person coding and design bootcamp that offers housing at no extra cost for immersive students. And they even have career services that can help you with job placement after you graduated. Dev Mountain loves hearing from my subscribers, so be sure to click on the link in the description tab below if you or somebody you know is ready to dive into coding and design. Hey guys, what's up? All right, so in this video, what I'm going to be talking about is 10 technologies that I think you need to master in order to get a job as a web programmer. Now, this isn't exhaustive, but I think that honestly, if you do master these 10 things and you're able to actually show your work out there, that it's going to speak for itself. And if you get good enough in this gig, like there's no question you'll be able to find a job. It's like inevitable. And a lot of people don't even want jobs. They know how to make money, you know, as freelancers and all this other stuff. So you might decide that that's what you want to do. But the point is that if you master this stuff, that you will find work. And then also for people that don't know, I've been doing professional development now for 10 years, but I'm self-taught in the sense that I didn't go to school. I went to school for business and dropped out, but I never took computer science courses or anything like that. So I ended up taking like the hard road of building my own company, websites, all this other stuff. And eventually I was able to show that as a portfolio to get hired. So things have changed a lot in the 10 years that I've been doing this. And like when I was first getting started, the technology's always changed. Like whatever the hot tools are, they're always fading in and out. So this list is going to pertain to what is hot right now. All right, guys, so number 10 on this list is going to go to Chrome, and you heard that right. If you want to be a web developer, you have to understand how the browser works. So you need to become familiar with it. You need to have it on your computer, obviously. We use browsers, but you're going to use it. We use it in our daily lives, obviously, and people that are not programmers use browsers, but you're going to use a browser in a much different way as a programmer. So the better you are with that, the more easier you're going to be able to debug your code. Everything for web development can pretty much be debugged right inside the Chrome browser these days. That's something that we did not have the capabilities of 10 years ago. So right-clicking or pressing F12 will pull up the Chrome developer tools. And all of these tabs are things that you need to familiarize yourself with. It's going to take probably years in order to really understand how all of this stuff works. So, you know, don't be hard on yourself when you don't understand certain things. But literally everything can be like debugged right here. You can even do like memory profiles, like this thing says. Like, you can actually start recording, and it's like it pays attention to every little detail so that you can try to make your website more efficient. So the reason why I say Chrome and not Firefox, I have a video that I did a couple weeks ago or months ago where I'm comparing Firefox to Chrome, and honestly, they're both head-to-head very good. In fact, Firefox is probably slightly better when it comes to developer tools. The problem is that literally everybody's using Chrome, so like you want to make sure your website works on Chrome first and foremost, because look at this global traffic that is going and using Chrome browsers. So you know, these other browsers you want to support, but they're not nearly as important as this one. So that's why I recommend Chrome. All right, so number 9 is going to go to Visual Studio Code. There's all these different editors. 10 years ago, there was even more popular editors. Like it was like a tie between like, it seemed like 10 of them. It can be daunting though, which editor to pick. I mean, people are going to be recommending PyCharm from the Python community. You got Visual Studio, the IDE from like the .NET community. You got Eclipse from the Java community. Like, which one do you choose? And the answer is you choose Visual Studio Code. Most development shops are using this for web development, so this should be your default editor. You should at least understand how this is working before you start using some other tool, especially a proprietary tool that is more than likely not being used widely across the industry. And that's not to say that like PyCharm isn't used widely. The point is web development, this is the most widely used text editor right now. So after you download Chrome, you start learning the Chrome tools and all that stuff. You start learning how you can just basically inspect the page with Chrome, get familiar with that. Then you need to start writing code that you're going to run inside of Chrome. And to write that code, you have to use Visual Studio Code. So this list is in order. These are things that you should do in order. All right, so number 8 is going to be HTML, and that is the basic starting point of your web development. You have to understand HTML, and that's now that you have Visual Studio Code installed, you can go ahead and start actually hacking away and creating your own stuff. So we can create a test.html file. I could probably press HTML or just type it in to VS Code if I like. I should get some help on this. What the hell? Is it .html? Now it's working. All right, anyway, I can just click HTML5. It's going to build this out. There's your HTML skeleton, and you need to understand that these elements are how web pages are composed. It's the skeletal makeup of it. These meta tags are pertaining to viewports and all this stuff that are for mobile phones, but you'll learn that later. This just helps search engines and stuff try to figure out what type of language your website is all about. And then every element in HTML, you have things like this is the actual element, it has an opening and closing point. You have stuff in it that's going to appear. This appears. And then you have things called attributes and or properties. And that's really the gist of HTML. But it does take a long time to get there because there's a lot of different types of elements, and every different type of element has certain type of attributes you can reference. But there are common ones though that all elements have, like class. You can put unique classes for styling and stuff like that. But these are called attributes. So really, that's all HTML pages are. They're just elements with these attributes. All right, so next one on the list is going to go to CSS. You need to understand how CSS styles a page. So HTML is the skeletal makeup, and then our skin of the page is going to be all done with CSS. That's how we make things look pretty. Every website is literally just HTML elements with CSS. Here's the HTML elements on the left-hand side. On the right-hand side, you have styles. These are all CSS rules, and this is what's giving this page this look and feel. You can actually dynamically switch all this stuff. I can start switching the colors over here. That's one of the cool tools of Chrome that you have these days. You could just really start experimenting right in the browser without actually writing code. So CSS, there's a lot to it. I mean, it took me a long time to master CSS, literally years. And I'm not even really a master in the sense that, like, I still lack certain artistic creativity. So there's other CSS developers that are more artistically creative, and they just have that natural thing that I just don't have when it comes to actual visual art. But I can replicate anything I see in CSS. I have enough knowledge to do that, even if it's not to create things. It's beautiful art, because it still takes a certain artist to have really good design UX skills. So there's many ways to do CSS. You can actually put CSS is called in-page styling, where you just put the style right in the page. I can go ahead and target the H1 here, change its color to red. It's going to be black by default, but here's the H1 right now. And if I just want to go ahead and review this, I can say reveal in the Explorer. Open it up in Chrome. You can see this is red. How did it get red? It got red because of the style that we put on it. We put it right in the page, but honestly, they can be an external page. You could also put it in style by putting an attribute called a style attribute on the H1 and embed your style right in here. And this isn't recommended, but you'll see a lot of libraries these days are like doing this inline injection styling, like Tailwind and stuff for one, which I absolutely hate, by the way. I still do. Anyway, let's go ahead and look at this color, blue, and I can just go ahead and change that right in here, and I just changed it to blue. So that's all CSS, and there's multiple ways of doing it. Now, when you become familiar and get really good at CSS, just know that there's no CSS versionings anymore. There used to be CSS 1 and 2 and 3. There's not going to be a 4 anymore. So CSS just continues to make improvements, and browsers adopt those improvements. But you have to keep in touch with those improvements. And there's announcements and stuff with CSS groups and all that. But the point is that there's not going to be any sort of versioning, but CSS is improving and advancing over time. There's now things called like CSS animations. I was just talking about that in a previous video. I'm not going to go into all that stuff, but things do get really, really complex when it comes to CSS. Now, once you do master this, though, there is another thing you have to be familiar with, and that's called like Sass. There's tools called Less. Now, like I said, I mentioned Tailwind. So there's all these different tools out there that write CSS, but my thing is that you want to be good at the core of CSS. You want to be able to understand what CSS is doing and what new features you can tap into, and not rely on a library to have to adopt those features for you. So I think it's important for people to master CSS to its core. All right, so the next on this list is going to be JavaScript, and again, with like with CSS, there's multiple ways that you can do JavaScript. You can inject JavaScript right into the page just by putting a script tag anywhere. Anything that's inside of the script tag is going to be all JavaScript code that's executed, and I can do like a simple alert, hello world, and you can see we get the hello world pop-up. Now, most people are obviously going to put their JavaScript files as an external file. And then you would put all your code in here. It's much better. But the point is that there's going to be a lot when it comes to JavaScript. But the three core fundamentals of any programming and web development is that you have to understand HTML and how all that stuff works. You have to understand how CSS styling applies to that. You have to understand how browsers render all that content. And then you have to understand how JavaScript is used to then dynamically alter and modify that content on the fly, and sometimes behind the scenes, so the browser doesn't even give you any sort of interpretation or anything that JavaScript code is executing behind the scenes, but it's really just for all the manipulation that you need to do, like from even posting forms, like somebody's filling out a form and you need to post that to your server. JavaScript's handling all that stuff, and it takes a long time in order to master that, but you do have to have at least basic level JavaScript knowledge to build your websites and all that stuff. So I know that this part of the list is going to take a long time. It's not like you have to be an absolute master, but you do have to be like at least proficient enough to be able to use other people's JavaScript plugins and such, even if you're not creating them from scratch, and understand how to do basic things like obviously calling functions, passing in certain objects of key value pairs to make code behave a certain way and all that stuff. So once you get to that level, you can really start relying and just using other people's code. In fact, most programmers really are not actually creating this stuff from scratch. They're mostly just configuring things. All right, guys, so number 5 is going to go to Node.js. And the reason why you need to learn Node.js is because it's really the most popular tool that we're now using to install other development tools along the way. So like Node has injected itself into the web community almost in everything we do. So it's really, and really I have to just go ahead and explain it by example here. But one of the things you should know is they call it Node.js because you actually use JavaScript to write Node files and Node applications. You're writing it in JavaScript. However, JavaScript really just runs in the browser. So in what Node.js is, it's a runtime that was created with C, like C++, and you just use JavaScript as a scripting language for it, but it's not really JavaScript under the covers. But most of what you can do in like JavaScript, you can do in Node. There are some slight differences that will get you along the way. But let me just show you a quick example. Like if I were to go ahead and I have Node.js installed, I'm going to open this up in a terminal. And say I needed a web server, right? I wanted this HTML to be a web server so I can make requests to it, so I can get like, practice JSON data calls and all this other stuff. But I need a server. So with Node, I can use npm and I can just say init -y, which just says yes for everything. It's going to create this package.json to keep track of all my dependencies. And now if I just needed a server, I could just say npm install http server, which is a really popular like basic Node.js web server that kind of gives you everything you need to deliver HTML, CSS, and all the other stuff. And it's great for local development. So now that I have that, it's going to add that as a dependency here. I'll go ahead and make this smaller. And then now I can go ahead and add like a script. So I can just say like start is going to be the name of my script. And really this is just going to call internally that dependency that we just installed, which is HTTP server, which is automatically going to deliver any sort of content here. So now if I go back to my terminal, I can use Node and npm and just say npm run start. And now it's going to start my internal server. I can go to my localhost address. And then I get my hello world. So now this is being delivered from a localhost server versus a local file. So that gets me past like course header restrictions and cross-file scripting stuff that like, that's a long story, but anyway. All right, guys, so number 4 is going to go to Babel. And Babel is something that after you've started working with JavaScript code, there's a newer version of JavaScript that is always coming out. And the problem with that newer version of JavaScript that's always coming out is browsers have a hard time keeping track or keeping up to date with all these latest capabilities. So, like, for instance, this template literal syntax now is supported in Chrome, but for the longest time it wasn't. So we had to use Babel to write modern day JavaScript code, but Babel would automatically convert all that stuff to older code, everything you wrote to older code automatically, and that just works on any sort of browser that you wanted to target. Going all the way back to like crappy browsers like IE, which hardly anybody uses anymore, thank goodness. But that's what Babel gives you the ability to do. It gives you the ability to write tomorrow's JavaScript in the browser today. So you can see just even this turned it all to that on the right-hand side. So there's quite a bit involved here, but like the point is that using a tool like this allows you to keep up to date and start writing like modern JavaScript. And you can start in job interviews being like, yeah, I know how to do the spread operator, and all these different little like nuances, template literal syntax, arrow functions, all that stuff. That's stuff that we're now using commonly, but there's not now always a new way of doing something. There's a lot of now array lookups and things that make it easier to like parse arrays of JavaScript objects and stuff. So, keeping up to date with that is going to help you be able to go into a job interview and be like, yeah, I can, I have all the latest information in the JavaScript world. But again, when you're doing JavaScript, JavaScript was earlier on this list, and even though Babel is technically like writing JavaScript for you, this is a feature I think that comes after initial JavaScript. You should just write regular JavaScript first, then start using Babel with Node to convert your JavaScript code, and then you could say, yeah, I'm using all these latest tools and everything. All right, guys, the number 3 is going to be TypeScript. Now, very similar to how Babel works, TypeScript is essentially the same thing in a nutshell, but it's a completely separate language with its own separate features and interfaces and all these different things that the JavaScript world doesn't have, and for the longest time didn't have. Like TypeScript had classes before JavaScript had support for that. And TypeScript borrows very heavily from C#, so it's designed around like the C# type of ecosystem. And anyway, what TypeScript does is it allows you to write TypeScript. It really allows you to write JavaScript that they call it that scales and is also considered to be type safe. So type safety is something that is a long discussion. You could probably write books on it. But the point being that to explain it and sum it up is that TypeScript is used because there's so much code written around type checking in JavaScript that you have to do to prevent certain runtime errors from occurring that TypeScript does automatically for you. So if you write things the TypeScript way and you truly use and tap into the type safety, it's going to save you from a lot of bugs down the road. So that's why a lot of teams are moving over to TypeScript for their large JavaScript projects. The reason why I don't say learn TypeScript first is because a lot of TypeScript in the wild that I see has JavaScript sprinkled in all over the place. So it's like TypeScript can be a combination of TypeScript and JavaScript. And like I've seen it, and like you really should understand the difference between like what is TypeScript code and what is going to be outputted to actual JavaScript code. And really it takes understanding JavaScript first to understand TypeScript, in my opinion, really, really well. But eventually, though, when you start getting into production development and you go to most of these big shops, it's going to be one or the other. These big shops are going to be using JavaScript with Babel, and you're going to be writing modern JavaScript with a tool like Babel that's going to compile it for you, or you're going to be writing TypeScript, and then most likely you're going to be using a combination of both. So I've been saying for years now that you should learn both JavaScript and TypeScript because I've been seeing it in the wild interchangeably all the time. In fact, I write both of them all the time now. All right, guys, so number 2 is going to be Webpack, and a lot of people hate this tool in the wild, but this thing allows you to do so much. In fact, people hate this thing so much that we have tools like Create React Project and like Angular and Nuxt and Next and all this bullshit, and all it does is really just abstract away the core of like Webpack and Babel and a bunch of different plugin tools and stuff. Like you can create your own framework like very easily these days. Like I don't need Gatsby.js and all this bullshit to render a static website. Like as an example, this CodeHawk website right now, it's all generated, and I built it all in Node.js, so it's really Node, and yeah, and the whole thing, and like even though I'm not trying to say it's the most impressive thing or whatever, I'm talking though everything from the CSS to the blogs to the how they're rendered, how they're ordered, all this stuff that I wrote that I created is all spun up in just like literally a second. I press F5 and the entire website's created from scratch. And then I just deploy the website. How do I do that? I do it through a bunch of development tools that I just mentioned in this list, and that's all I use. But Webpack does a lot for me because Webpack allows me to automatically minify, allows me to uglify, it allows me to use a bunch of different modules that I can then import all together for bundling and all that stuff. It does automatic image conversions. Like there's so many different things that this tool can do. But the point is that you should be using it to abstract your code out, whether it's TypeScript or JavaScript, and then use this to be importing all of your modules and dependencies and bundle it all into one file. You shouldn't have a bunch of JavaScript files all over the place on your website these days. It should just be one bundled file that's minified, uglified, so it's efficient, can be cached, and it's all done through the magic of Webpack and Node and all this stuff that I mentioned on this list. All right, guys. Number one is going to be Git. So version control is a big thing in programming communities. Boot camps are focusing on learning and teaching you how to use Git, because any development shop you're going to go into, they're not going to let you write code that you can easily just save over somebody else's change and there's no record of it and all that crap. Git keeps track of all that stuff for you. Every project's going to use Git. If they're not using Git, they're using like a different flavor of version control. There's like Subversion and TFS and all this other stuff, but Git is by far and away the most efficient. It's free and it's the most widely used. It's what GitHub is built off of. So all the GitHub projects out there, they're all Git. So if you want to be good on GitHub, you want to do contributions and understand how these projects work and all that stuff, then you have to understand how Git works, and then you understand how GitHub works. But then you can start contributing your code, all the code that you wrote and everything that you've learned on the list. You start getting good with that stuff. How do you show people? Well, you show people on GitHub. You have to learn Git, so you can get it on GitHub. In addition to that, all of this technology comes together, and one of the great things about it, and I didn't mention on this list, and some of you guys might be wondering, like, well, what about the server, right? Like, what about a web framework and all this crap? That all comes after all this stuff. So if you get good at this stuff, you can get a website out there, tap into React next, tap into Angular next. I don't think that those things should be learned before the other things in this list, because you're just really not going to be able to tap into all this stuff with any sort of efficiency for a while, and not unless you have some more basic knowledge. Also for like server-side frameworks like Python Django, or whether you want to use Ruby on Rails or C# and ASP.NET or whatever it is that you use, you don't have to use any of that actually. For all the technologies I just mentioned, if you want to get it on the web, codehawk.com, my website here, I don't really use any frameworks for this. In fact, it is using Bootstrap, which is a CSS library, which saves me some time. But other than that, it's really just all my videos, all this stuff, it's all hosted. And I set up my own server and all that stuff, but I'm using Linode. And I don't use, like I said, a server-side framework. I don't need to. It's a static website that I've created in Node.js that I just deploy via Git to my virtual private server. And then under the covers, it's using both Apache and Nginx as the delivery for the static file. So that's all you need to do. I need a cloud account. I need a domain. I set up an account with Linode. I provision my Apache server or Nginx server or whatever server you want to use, and it delivers static files. Now, eventually, you may want to have a Python runtime or a Node runtime and a Node website and all that stuff. I have tutorials on all that, by the way, if you guys are interested. I explain all that stuff in really just the 12 tutorials I have out on this website right now. It kind of goes through all the stuff on this list. But the point being is that you can deliver a website like this for the world to see. Thousands of people visit this website every month. And it costs me next to nothing. And you can do it all in just the technologies I mentioned. So that's really it. That's going to wrap up this list. If you want to get a job, most jobs are in web development. There's still tons of demand. If you can become an expert in just the core basic HTML, CSS, and JavaScript, you're going to be able to find a job. Even if you were a super expert with artistic creativity and just HTML and CSS, you could still find work. But it's a little bit more difficult. The more you can master, the more you can be the more you can be plug and play in the different areas of web development, the better off you're going to be when it comes to finding employment. But that's really it. Let me know if I missed anything, guys. I appreciate all the support. Have a good day. Take care. Bye.